Chapter 9 Differential Equations. Let us see what are linear differential equations and we will see how to solve them. A differential equation of the form dy by dx plus py equal to q, where p and q are constants or functions of x, is called the first order linear differential equation. Now let us see how to solve this. We will take integrating factor as e power integral p dx. We will multiply the linear differential equation throughout by this integrating factor. We get e power integral p dx into dy by dx. The second term becomes p into e power integral p dx into y equal to q times e power integral p dx. Now see the left hand side. This is the differential of y into e power integral p dx equal to q times e power integral p dx. If we use product rule and differentiate this term, we get the previous step. Now integrating both sides, we get y is equal to e power integral p dx, because differentiation and integration will get cancelled. Here we will have integral q times e power integral p dx plus the constant of integration. Therefore, the formula is y into the integrating factor equal to integral q times the integrating factor dx plus c. In linear differential equations, we have two types. The first type is linear differential equations of the form dy by dx plus py is equal to q, where p and q are constants or functions of x. There shouldn't be y term in p and q. Then the solution is, first step is we find the integrating factor, which is e power integral p dx, and then the second step is we write the solution. The solution is y into integrating factor equal to integral q times integrating factor dx plus c. Now let us see the second type. The second type is dx by dy plus px is equal to q. In this case, p and q are constants or functions of y. There shouldn't be any x term in p and q. The first step is we find the integrating factor, which is e power integral p dy. Everywhere the integration has to be done with respect to y in this case. The second step is the solution step. X into integrating factor. In the previous type, it is y into the integrating factor. Here x into integrating factor equal to integral q into integrating factor dy plus c. Memorize these formulae. The first type is dy by dx type. The second type is dx by dy. Integration has to be done with respect to y in the second case. Let us do exercise 9.6. For each of the differential equations given in exercises 1 to 12, find the general solution. The first question, dy by dx plus 2y equal to sin x. Now this is of the linear differential equation form dy by dx plus py equal to q, where p is 2 and q is sin x. Here p is a constant and q is a function of x. We will find the integrating factor. The integrating factor formula is e power integral p dx, which is e power integral p is 2 dx. An integral of 1 is x. In the integrating factor, for this integral, no need to write the constant of integration. We will write c at the end in the solution. We will write the solution formula. The formula is y into integrating factor equal to integral q times integrating factor dx plus c. Y times the integrating factor is e raised to 2x equal to integral q is sin x into e power 2x dx plus c. Now to do this integral where we have sine and exponential function, we have to do integration by parts 2 times. We will take that as I integral sine x e power 2x dx. We will take e power 2x as the second function and sine x as the first function. In I late, e letter comes last. Always exponential function is the second function. The formula is first function into integral of the second function. Integral of e power 2x is e power 2x divided by 2 minus integral differential of the first function. Differential of sin x is cos x times integral of e power 2x is e power 2x divided by 2 dx. We will do integration by parts again by taking cos x as the first function and e power 2x as the second function. Half into sin x times e power 2x minus half can be taken out and use brackets because we are going to write two terms and this minus half is common to both the terms. First function into integral of the second function. Integral of e power 2x is e power 2x divided by 2 minus integral differential of the first function. Differential of cos x is minus sin x, minus into minus is plus sin x, and integral of e power 2x is e power 2x over 2 dx. Half into sin x times e power 2x minus 1 by 4 times cos x e power 2x and minus 1 by 4 times, we have half here as well as half here, 1 by 4 times integral sin x e power 2x dx can be written as I. We took this integral as I. On the left hand side also we have I. Bring this minus 1 by 4 I to the left hand side. I plus 1 by 4 I, which becomes 5 by 4 times I. Half into e raised to 2x is common, sin x minus half cos x. Therefore, I is 4 by 5 times half e power 2x times sin x minus half cos x. Now we will substitute this answer in equation number 1. Therefore, equation 1 becomes y e raised to 2x equal to, that integral answer is 2 by 5 times e power 2x times sin x minus half cos x plus c. We will take half out, half into 2 sin x minus cos x plus c. We will divide the whole equation by e raised to 2x. Y is equal to 1 by 5 times 2 sin x minus cos x plus c divided by e power 2x. Don't write this term as some other constant a. This is not a constant. E power 2x is not a constant term. Therefore, the answer is y is equal to 1 by 5 times 2 sin x minus cos x plus c times e power minus 2x. Question 2. The equation is dy by dx plus 3y equal to e raised to minus 2x. Now this is in the form dy by dx plus py is equal to q, where p is 3 and q is e raised to minus 2x. We will find the integrating factor. The formula is e raised to integral p dx, which is e raised to integral p is 3. Therefore, the integrating factor is e raised to 3x. Now, let us write the solution formula. Y into integrating factor equal to integral q times integrating factor dx plus c. Y times e raised to 3x equal to integral q is e raised to minus 2x times e power 3x dx plus c. We will simplify these two. E raised to, it becomes minus 2x plus 3x, which is x. Integral of e raised to x is e raised to x and plus c. Let us divide the whole equation by e raised to 3x. Y is equal to e power x divided by e power 3x plus c divided by e power 3x, which can be written as e raised to minus 2x plus c times e raised to minus 3x. I have told you, don't write this term as some other constant. It is not a constant anymore because we have e power 3x term. Question 3. The equation is dy by dx plus y divided by x is equal to x square. This is of the linear differential equation form dy by dx plus py equal to q, where p is 1 divided by x and q is x square. We will find the integrating factor. The formula is e raised to integral p dx, which is e power integral p is 1 by x dx. An integral of 1 divided by x is log of absolute value of x. Exponential function and logarithmic functions are inverse functions. They cancel each other. We get x. And in the integrating factor, for this integration, no need to write plus c. We will write plus c at the end when we write the solution. Now we will write the solution formula. Y into integrating factor equal to integral q times integrating factor dx plus c. Y times integrating factor is x equal to integral q is x square times integrating factor is x dx plus c, and this becomes integral x cube dx. Therefore, the answer is xy is equal to x raised to 4 divided by 4 plus c. Question number 4. dy by dx plus secant x times y is equal to tan x. 0 less than or equal to x less than pi by 2. This equation is also in the linear form dy by dx plus py equal to q, where p is secant x and q is tan x. We will find the integrating factor e power integral p dx, which is e power integral p is secant x dx. Integral of secant x is log of absolute value of secant x plus tan x. We can cancel e and log functions. The answer becomes secant x plus tan x. You need not write the absolute value sign because we have removed the logarithmic function. And no need to write plus c in the integrating factor. We will write 1c at the end in the solution. Now let us write the formula for the solution. Y into integrating factor equal to integral q times integrating factor dx plus c. Y times the integrating factor is secant x plus tan x equal to integral q is tan x times integrating factor is secant x plus tan x dx plus c. We will distribute this tan x. It is tan x secant x dx plus integral tan square x dx plus c. We have direct integration formula for secant x tan x, but we don't have for tan square. We will change tan square as secant square x minus 1 identity, because we have direct integration formula for secant square x. Now let us integrate and write y times secant x plus tan x is equal to integral of secant x tan x is secant x plus integral of secant square x is tan x minus integral of 1 with respect to x is x and plus c. Question number 5. Cos square x times dy by dx plus y is equal to tan x. 0 less than or equal to x less than pi by 2. We will bring this equation to the linear form dy by dx plus py equal to q. To do so, we have to divide by cos square x. We get dy by dx plus y divided by cos square x equal to tan x divided by cos square x. And 1 divided by cos square can be written as secant square. Right hand side is tan x times secant square x. Now p is secant square x and q is tan x times secant square x. We will find the integrating factor, which is e power integral p dx. E power integral p is secant square x dx. E power integral of secant square is tan x. Now we will write the solution formula. Y times the integrating factor equal to integral q times integrating factor dx plus c. We will substitute for the integrating factor, which is e power tan x equal to integral q is tan x times secant square x and integrating factor is e raised to tan x dx plus c. We will do this integration by substituting tan x as t, because we have combination of tan and secant square. We will substitute tan x as t. Secant square x dx becomes dt. Therefore, the integral becomes tan x is t, secant square x dx becomes dt, and we have e power tan x, which is e power t. Now we will do this by using integration by parts. First function, second function. First function, into integral of the second function. Integral of e raised to t is e raised to t minus integral differential of the first function, which is 1, and integral of the second function dt plus c. T e power t minus integral of e power t is e power t plus c. Now we will substitute for t. T is tan x. We will divide the whole equation by e power tan x. Dividing by e power tan x, we get y is equal to tan x minus 1 plus c divided by e power tan x. Therefore, the answer is y is equal to tan x minus 1 plus c times e power minus tan x. Question number 6. X times dy by dx plus 2y is equal to x square log x. Again, this is not in the standard linear differential equation form. We will divide by x throughout. Dy by dx plus 2 divided by x times y equal to x log x. Now, this equation is in the linear differential equation form. Dy by dx plus py equal to q, where p is 2 over x and q is x log x. We will find the integrating factor, which is e power integral p dx e raised to integral p is 2 divided by x dx e raised to 2 times integral of 1 divided by x is log of absolute value of x. In this case, we cannot cancel e and log functions because of this 2. We will take this 2 as the power. It becomes e raised to log of x square. Because of x square, I didn't write the absolute value sign. Now we can cancel e and log functions. The answer becomes x square. Let us write the solution formula. Y times integrating factor equal to integral q times integrating factor dx plus c. We will substitute for the integrating factor. Y times x square is equal to integral q is x log x times x square. So, it becomes x cube. X into x square is x cube dx plus c. We will use integration by parts method. X cube is an algebraic function. Log x is logarithmic function. L comes first. First function, second function. First function into integral of the second function. Integral of x cube is x raised to 4 by 4 minus integral differential of the first function. Differential of log x is 1 divided by x into integral of the second function dx plus c. X power 4 divided by 4 log x minus 1 by 4 times integral of x cube is x raised to 4 divided by 4 plus c. We will take x raised to 4 divided by 16 common. We get 4 log x minus 1 plus c. Now, we will divide throughout by x square. Therefore, y is equal to x square divided by 16 times 4 log x minus 1 plus c divided by x square. Question number 7. X log x dy by dx plus y is equal to 2 over x log x. We will divide the whole equation by x log x to bring it to linear differential equation form. Dy by dx plus y divided by x log x equal to 2 by x log x divided by x log x. dy by dx plus 1 by x log x times y equal to 2 divided by x square. Now this equation is in the linear form, where p is 1 divided by x log x and q is 2 divided by x square. We will find the integrating factor, which is e raised to integral p dx. E raised to integral p is 1 upon x log x times dx. To integrate this, we will substitute log x as t. Differential of log x is 1 by x, which is there in the function. Therefore, it becomes e power integral 1 by x dx is dt divided by log x is t. Integral of 1 divided by t is log of absolute value of t. E and log functions can be cancelled. We get t, which is log x. Here we need not write the absolute value sign because log x is already given in the question. We will write the solution formula. Y into integrating factor equal to integral q times integrating factor dx plus c. Y times the integrating factor is log of x equal to integral q is 2 divided by x square and integrating factor is log x dx plus c. We will write this as 2 times integral x raised to minus 2 log x dx. This has to be done by integration by parts method. A is an algebraic function, log x is logarithmic, L comes first. Log x is the first function, x raised to minus 2 is the second function. 2 times first function into integral of the second function. Integral of x raised to minus 2, we will use x raised to n plus 1 by n plus 1 formula. It becomes x power minus 1 by minus 1 minus integral differential of the first function. Differential of log x is 1 divided by x times integral of the second function plus c. 2 times minus log x divided by x. Minus of minus is plus integral x raised to minus 2 dx. 1 by x is x raised to minus 1. Already x raised to minus 1 is there in the numerator. Therefore, it becomes x raised to minus 2. 2 times minus log x over x plus integral of x raised to minus 2 is x raised to minus 1 divided by minus 1 using x power n plus 1 divided by n plus 1 formula. Y log x is equal to 2 times minus log x over x minus 1 over x plus c. Therefore, y log x is equal to 2 divided by minus 1 by x is common. We get 1 plus log x plus c. Question 8. 1 plus x square times dy plus 2xy dx equal to cot x dx, where x is not equal to 0. We have to bring it to the linear form. We will divide throughout by 1 plus x square dx. We get dy by dx plus 2xy divided by 1 plus x square, dx and dx will get cancelled. Here cot x divided by 1 plus x square, again dx and dx will get cancelled. Now this equation is of the linear form, dy by dx plus py equal to q, where p is 2x over 1 plus x square and q is cot x over 1 plus x square. Let us find the integrating factor, which is e raised to integral p dx. E raised to integral p is 2x over 1 plus x square. And this integration is easy. We will substitute the denominator as t. Differentiating both sides, we get 2x dx is equal to dt, which is the numerator, e power integral dt by t. An integral of 1 by t is log of absolute value of t. E and log are inverse functions. They cancel each other. We get t. And t is 1 plus x square. Let us write the formula for the solution. Y times the integrating factor equal to integral q times the integrating factor dx plus c. Y into integrating factor is 1 plus x square equal to integral q is cot x divided by 1 plus x square, and the integrating factor is also 1 plus x square dx plus c. Integration is so easy to do. Integral of cot x is log of absolute value of sin x. Be thorough with all integration formulae. Plus c. We can divide the whole equation by 1 plus x square. We get y is equal to 1 plus x square whole raised to minus 1. We are dividing by 1 plus x square times log of absolute value of sin x plus c divided by 1 plus x square, which can be written as 1 plus x square whole raised to minus 1. Question number 9. X dy by dx plus y minus x plus xy cot x equal to 0, where x is not equal to 0. We will divide the whole equation by x to bring it to linear form. Dy by dx plus y by x minus 1 plus y cot x equal to 0. Now we will combine these two y terms. Dy by dx plus y is common. We get 1 by x from the second term, and from the last term we get cot x equal to, taking this minus 1 to the other side. Now this has been written in the linear form. Dy by dx plus py equal to q, where p is 1 by x plus cot x and q is 1. P and q are either constants or functions of x. We will find the integrating factor, which is e raised to integral p dx. E raised to integral p is 1 by x plus cot x times dx. E raised to integral of 1 by x is log of absolute value of x plus integral of cot x is log of absolute value of sin x. We will combine these two log terms. E raised to log of x times sin x. Log a plus log b is log of a into b. Now we can cancel e and log functions. Integrating factor becomes x sin x. Let us write the solution formula. Y times the integrating factor equal to integral q into integrating factor dx plus c. Y times the integrating factor is x sin x equal to integral q is 1 integrating factor is x sin x and plus c. We will use integration by parts method. In isolate, x is an algebraic function, sin x is the trigonometric function. Algebraic function comes first. X is the first function, sin x is the second function. First function into integral of the second function. Integral of sin x is minus cos x minus integral differential of the first function. Differential of x is 1 into integral of sin x. Integral of sin x is minus cos x. So, minus of minus plus it becomes minus x cos x. Integral of cos x is sin x. We will divide the whole equation by x sin x. We get y is equal to, x gets cancelled, cos x divided by sin x is cot x plus sin x will get cancelled, we get 1 by x plus c divided by x sin x. Question number 10. X plus y times dy by dx equal to 1. We have two methods to solve this question. We can do by linear differential equation method, or by substituting x plus y as t. We can do by variable separable method also. Here we will solve by linear differential equation method. We will write dx by dy, which is x plus y. It can be written as dx divided by dy minus x equal to y. Now, this is in the linear differential equation form. Dx by dy plus px is equal to q, where p and q are either constants or functions of y. P is minus 1. It is very important to take along with the negative sign. P is minus 1. Otherwise, the whole answer will go wrong. And q is y. We will find the integrating factor. Here integration has to be done with respect to y everywhere. Integrating factor is e raised to integral p dy. E raised to integral p is minus 1. E raised to minus y. Now let us write the solution formula. It is not y into, it is x into integrating factor, because this is the second type of linear differential equation, equal to integral q times the integrating factor dy plus c. X into integrating factor is e raised to minus y equal to integral q is y, e raised to minus y dy plus c. Integration by parts method. First function into integral of the second function. Integral of e raised to minus y is e raised to minus y over minus 1. You have to divide by the coefficient of y. Minus integral differential of the first function. Differential of y with respect to y is 1 into integral of e power minus y is e power minus y by minus 1 dy plus c minus y e power minus y, minus of minus is plus, integral of e power minus y is e power minus y divided by minus 1 plus c. X e power minus y is equal to minus y e power minus y minus e power minus y plus c. We will divide throughout by e power minus y. The equation becomes x is equal to minus y minus 1 plus c divided by e power minus y. Therefore, the solution is x plus y plus 1 equal to c times e power plus y. Question number 11. Y dx plus x minus y square times dy equal to 0. x minus y square times dy is minus y dx. If I write dy by dx, I will get minus y upon x minus y square. I get two terms in the denominator. I cannot separate it. If I write the reciprocals, let us flip both the sides. X minus y square divided by minus y, so that I can separate the terms. The first term is minus x over y. The second term becomes y. Therefore, dx by dy plus x over y equal to y. We have written this differential equation as dx by dy plus px is equal to q, where p and q are functions of y or constants. Here p is 1 divided by y and q is y. Here they are the functions of y. No x should be there. We will write the integrating factor e raised to integral p dy. Everywhere integration has to be done with respect to y. E raised to integral p is 1 over y, which is e power log of y. E and log could be cancelled. The integrating factor is y. Now we will write the solution step. X into integrating factor equal to integral q times integrating factor dy plus c. Let us substitute x times the integrating factor. Integrating factor is y equal to integral q is y and integrating factor is also y. It becomes y square dy plus c. And integral of y square is y cube over 3 plus c. We will divide throughout by y. We get x is equal to y square divided by 3 plus c divided by y. Question 12. X plus 3y square times dy by dx equal to y, where y is greater than 0. We will write dy by dx, which is y over x plus 3y square. It is similar to the previous question. We cannot separate the terms, and it is not homogeneous also. See the degrees. Degrees are not the same. So we will take it as dx by dy, so that we can separate the terms as x divided by y plus 3y. We will write it in the linear form, dx by dy minus 1 by yx equal to 3y. This equation is in this linear form. P is minus 1 over y and q is 3y. In this type, p and q are functions of y or constants. Let us find the integrating factor. E power integral p dy. E power integral p is minus 1 over y, which is e raised to minus log of absolute value of y. We cannot cancel e and log functions because of this negative sign. We will take this negative sign as the power. E raised to log of y raised to minus 1. Now e and log functions can be cancelled. We get y power minus 1, which is 1 divided by y. Let us write the solution formula. X into integrating factor equal to integral q times integrating factor dy plus c. X times 1 by y equal to integral q is 3y times 1 by y dy plus c. Y and y are getting cancelled. And integral of 3 dy is 3y plus c. Therefore, x is 3y square plus cy. For each of the differential equations given in exercises 13 to 15, Find a particular solution satisfying the given condition. These are initial value problems. Question number 13, dy by dx plus 2y tan x equal to sin x. Y is 0 when x is pi by 3. This equation is already in the standard form. Dy by dx plus py is equal to q, where p is 2 tan x and q is sin x. Remember, p and q are functions of x or constants. Don't write p as 2y here. The integrating factor is e raised to integral p dx, which is e raised to integral p is 2 tan x dx. E raised to 2 times integral of tan x is log of absolute value of secant x. We cannot cancel e and log functions because of this 2. We will take it as the power. It becomes e raised to log of secant square x. Now e function and log function could be cancelled. The integrating factor is secant square x. We will write the solution formula. Y times the integrating factor equal to integral q times the integrating factor dx plus c. Integrating factor is secant square x and q is sin x. I can write secant square as 1 by cos square. Sin x by cos x is tan x and 1 divided by cos x is secant x. And we have direct formula for integral of tan x secant x, which is secant x. And this is an initial value problem. Y is 0 when x is pi by 3. Let us substitute these values. The left hand side becomes 0. Secant pi by 3 plus c. Secant pi by 3 is 2. Therefore, c value is minus 2. Now we will write the particular solution. Y times secant square x equal to secant x minus 2. Therefore, y is 1 by secant x minus 2 divided by secant square x, that is dividing by secant x, which becomes cos x minus 2 cos square x. Let us do question number 14. The equation is 1 plus x squared times dy by dx plus 2xy equal to 1 upon 1 plus x square. Y is 0 when x is 1. Now to bring it to the standard form, we will divide by 1 plus x square. Therefore, dy by dx plus 2x divided by 1 plus x square times y equal to 1 divided by 1 plus x square the whole square. This equation is of the form dy by dx plus py equal to q, where p is 2x divided by 1 plus x square and q is 1 divided by 1 plus x square the whole square. Both are functions of x. We will find the integrating factor e power integral p dx. E power integral p is 2x upon 1 plus x square. Integration is easier to do. By substituting the denominator as t, we get 2x dx as dt. E power integral dt over t. An integral of 1 by t is log of absolute value of t. We can cancel e and log functions. We get t and t is 1 plus x square. We will write the solution formula. Y into integrating factor equal to integral q times integrating factor dx plus c. The integrating factor is 1 plus x square. Y times 1 plus x square equal to integral q is 1 divided by 1 plus x square the whole square times integrating factor is 1 plus x square. And integral of 1 divided by 1 plus x square is tan inverse of x. And this is an initial value problem. Let us substitute y as 0 and x as 1. The left hand side becomes 0. Tan inverse of 1 plus c. Tan inverse of 1 is pi by 4. Therefore, we get c as minus pi by 4. Let us substitute this value of c in the general solution to get the particular solution. Therefore, y times 1 plus x square equal to tan inverse of x minus pi by 4. Question number 15. dy by dx minus 3y cot x equal to sine 2x. And the initial conditions are y is 2 when x is pi by 2. This equation is already in the linear form. dy by dx plus py equal to q, where p and q are functions of x. dy by dx minus 3 cot x y equal to sine 2x. Let us write p and q. P is equal to, along with the sign you have to take, very important, otherwise the whole answer will go wrong, minus 3 cot x, and q is sine 2x. We will find the integrating factor e power integral p dx. E power integral p is minus 3 cot x dx. And integral of cot x is log of absolute value of sin x. We cannot cancel e and log unless we take this as the power, which is e power log of sin power minus 3x. Cancelling e and log functions, we get sin power minus 3x, which is 1 divided by sin cube x. The solution formula is y times the integrating factor equal to integral q into integrating factor dx plus c. Y times 1 divided by sin cube x equal to integral q is sin 2x times the integrating factor is 1 upon sin cube x dx plus c. We will simplify this function. We will write sin 2x as 2 sin x cos x divided by sin cube x. Two times integral cos by sin is cot x and 1 divided by sin is cosecant x dx plus c. And integral of this is minus cosecant x. Y divided by sin cube x is minus 2 divided by sin x. 1 divided by sin x is cosecant x plus c. We will multiply the whole equation by sin cube x. Therefore, the solution is y equal to minus 2 sin square x plus c times sin cube x. This is an initial value problem. Here y is 2 when x is pi by 2. 2 is equal to minus 2 sin 90. Sin 90 is 1. 1 square is 1 plus c times sin 90, which is 1. Therefore, C value is 4. Let us substitute this C value in the general solution to get the particular solution. Y is equal to minus 2 sine square x plus 4 sine cube x. Question number 16. Find the equation of a curve passing through the origin given that the slope of the tangent to the curve at any point xy is equal to sum of the coordinates of the point. The point of contact is x comma y and slope of the tangent at this point is dy by dx, and it is given in the question that the slope of the tangent at x comma y is equal to sum of the coordinates of this point. Therefore, dy by dx is x plus y. We will write it in the linear form dy by dx minus y is equal to x, or we can solve this by substituting x plus y as t and then using variable separable method. This is in the linear form dy by dx plus py equal to q, where p is minus 1, be careful with the sign, q is x. P and q are functions of x or constants. We will find the integrating factor, which is e raised to integral p dx. E raised to p is minus 1. Therefore, integrating factor is e raised to minus x. Now, let us write the solution. Y into integrating factor equal to integral q times the integrating factor dx plus c. Y into integrating factor is e raised to minus x equal to integral q is x, integrating factor is e power minus x plus c. We will integrate by using integration by parts method. First function into integral of the second function, which is e power minus x divided by minus 1, minus integral. Differential of the first function is 1 and integral of the second function is e raised to minus x divided by minus 1 dx. Minus x e power minus x plus integral e power minus x dx plus c. Integral of e power minus x is e power minus x divided by minus 1. Therefore, the solution is this is the general solution, and it is given that it passes through the origin. When x is 0, y is 0. Let us substitute 0, 0, e raised to 0, which is 1 plus c. Therefore, c value is 1. We will write the particular solution. Y times e power minus x is minus x e power minus x minus e power minus x, c is 1. We will divide the whole equation by e raised to minus x. Therefore, y is minus x minus 1 plus 1 divided by e raised to minus x. Therefore, the solution is y plus x plus 1 is equal to e raised to x. Question number 17. Find the equation of a curve passing through the point 0, 2 given that the sum of the coordinates of any point on the curve exceeds the magnitude of the slope of the tangent to the curve at that point by 5. We will take the point as x comma y, and it is given that sum of the coordinates, that is x plus y at this point on the curve, exceeds the magnitude of the slope of the tangent by 5. This equation can be solved by taking x plus y minus 5 equal to t and then using variable separable method or using linear differential equation method. Therefore, dy by dx minus y is equal to x minus 5. Now this is in the form dy by dx plus py equal to q, where p is, take along with the sign, very important, p is -1 and q is x minus 5. In this case, p and q are functions of x or constants. We will find the integrating factor, which is e power integral p dx, e power integral -1 dx. Therefore, the integrating factor is e raised to minus x. We will write the solution. The formula is y times the integrating factor equal to integral q times the integrating factor dx plus c. Y into e power minus x equal to integral q is x minus 5 e power minus x dx. We will take e power minus x as the second function, x minus 5 as the first function. First function into integral of the second function. Don't forget to divide by the coefficient of x, which is -1, minus integral differential of the first function. Differential of x is 1, differential of 5 is 0. Therefore, differential of the first function is 1, and integral of the second function, which is e power minus x divided by -1. I will change the sign here, it becomes positive. Minus x minus 5 e raised to minus x, and integral of e raised to minus x is e raised to minus x divided by -1 plus c. We will multiply throughout by e raised to x. Therefore, we get y equal to minus of x minus 5 and -1 plus c e raised to x. This is an initial value problem. It is given that it passes through 0, 2. That is, when x is 0, y is 2. Let us substitute these values. 2 is minus 0 minus 5 minus 1 plus c times e raised to 0. E raised to 0 is 1. Therefore, c value is 2 minus 4, which is minus 2. We will write the particular solution. Y is equal to minus x plus 5 minus 1. C is minus 2. Therefore, the solution is y is equal to 4 minus x minus 2 e power x. Question number 18. The integrating factor of the differential equation x times dy by dx minus y equal to 2x square is. Let us bring it to the standard form. We will divide by x throughout. Dy by dx minus 1 by xy equal to 2x square divided by x becomes 2x. Now, this is in the linear form dy by dx plus py equal to q, where p is, I have told you to take along with the sign, this is your p, minus 1 over x, and q is 2x. Both are functions of x. We have to find the integrating factor. The integrating factor is e power integral p dx, which is e power integral minus 1 by x dx, e power minus log of absolute value of x. We cannot cancel e and log because of this negative sign. We will take this as the power. It is e power log x raised to minus 1, which becomes 1 by x. C option is the correct option. Question number 19, the last question of this exercise. The integrating factor of the differential equation 1 minus y squared times dx over dy plus yx equal to ay minus 1 less than y less than 1 is. We will divide the whole equation by 1 minus y square. This differential equation is of the form dx by dy plus px is equal to q, where p and q are functions of y. P is y divided by 1 minus y square and q is a y divided by 1 minus y square. We have to find the integrating factor, which is e power integral p dy, e power integral y divided by 1 minus y square dy. We will substitute 1 minus y square as t, minus 2y dy becomes dt, e power integral dt divided by minus 2 divided by the denominator is t, e power minus half log of absolute value of t. Now to cancel e and log functions, we will take this minus half as the power. We get e raised to log of t power minus half. Now cancel e and log, we get t power minus half, which is 1 by root t, which is equal to 1 divided by root of 1 minus y square. The correct option is D.